In this demo, we're going to get the AWS card application from the repository, analyze it with Probe, replatform and refactor it with Heirloom, and deploy it as a cloud-native Java application to a local Apache Tomcat server. Data migration of the datasets to a database and deployment of the same application package to 3 cloud platforms will be shown in subsequent videos. We've started our Docker image of Probe in the repository folder, which is all Probe needs to begin its analysis. Probe performs a lot of different functions, but the objective here is to ensure that we have a complete application inventory. As you can see, Probe is very fast, so let's see what it's found. Here's a list with some basic application statistics. It seems we are actually missing a transaction, so let's examine the graph database to find out more about that. We're going to execute a query to identify all the online transactions in this application. And as we can see, the missing application asset is highlighted as a blue circle, and by expanding its relationships we can see at this stage in the application's lifecycle it is not used by any other program, which means it is not of any immediate concern to us. Mainframe applications are composed of many different assets, as can be seen by examining the relationships of one of the programs. Expanding all relationships for the application gives us a system-wide view. With the analysis complete, let's move on to transpiling the application. This is the Heirloom IDE, and the first thing we're going to do is create a project for the online application. We're then going to populate the project by simply dragging and dropping the application assets from the open source repo. This project would then become a migration repo and be integrated into a CI/CD pipeline. The online application assets include BMS maps for the screens, COBOL source and copybooks for both. We know from Probe's analysis that this online application is comprised of these particular program sources. At another time, we will take a closer look at the backside of the application, which is built in much the same way and executed using the existing JCL. Once we have all the required assets in the project, we'll be able to transpile the code to Java source code, which then gets compiled by the Java compiler into classes for execution. By the way, transpilers are a type of compiler that produce source code. They're also very common. In fact, the compilers on the mainframe are also transpilers. They emit assembler source, which then gets compiled by the assembler compiler into machine code for execution. Heirloom's core technology uses transpilers because they provide language coherence, giving you the choice to develop the application in the original language or in Java. We'll save this topic for another time, but this kind of flexibility puts you in complete control of your post-migration modernization journey. Everything is now in place, so we are ready to build the project. I'm going to turn on automatic builds from here, and as soon as I do, the application will be compiled. And any subsequent save changes will get automatically compiled also. As you can see, we did get one error, so let's take a look and find out what's wrong. Well, it seems we have a redefines that is redefining itself, and even though it's nonsensical, the mainframe compiler simply ignores the error. As soon as we fix it, the program is compiled again and the error is now gone. It is not necessary for warnings to be resolved, but I don't know about you, but they annoy me, so let's take a look anyway. The first one is a duplicate paragraph name, which is easily fixed by simply removing one of the duplicates. The program is saved, and this particular warning has now been resolved. The last one is a misaligned level number for one of the record structures. It's best practice for data items within a record to all follow the same descending numeric structure. So let's fix this by putting in the expected O5 level identifier. With this change saved, the warning is also resolved, and we now have a completely clean build. Let's clean this up a bit and take a look at the Java produced by the compiler. Here are all the Java classes. One class is produced for each COBOL program. Then within each class you're going to see a collection of Java methods. One method is produced for each COBOL paragraph. Here's one of the Java methods, and as you can see from the source, we have a compiler option set to embed the original COBOL source's comment. This is a basic form of documentation that can help during any subsequent refactoring. Although we haven't migrated any data yet, that will be shown in the next video, we do need to make sure that we have the JDBC driver for our database on the build path. To deploy the application, we need to create a deployment project to describe and configure the application environment. At this stage, we're going to target a local instance of Apache Tomcat to provide us with the execution environment. The deployment project is already linked to our application and has the correct configuration for our target database, as well as a mapping of the transaction IDs to programs. We're now going to deploy the application as a standard Java war package to the local Tomcat server that you can see on the right side of the screen. Once the export is completed, the Tomcat server will pick up the package and deploy it. The application is now ready to run. The application's initial screen is rendered in the browser and will behave and function exactly as it does on the mainframe. We have not migrated any data yet, so any attempt to sign into the application will not work. Nonetheless, the application is already executing as expected, and once we get the data in place, which again we will cover in the next video, we will be able to begin our unit testing prior to deploying the application to our target cloud platforms.